Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing some more terminologies relating with object-oriented model. So my dear students, in the last lecture, we have discussed the terms like object, class, encapsulation, data hiding, message passing, inheritance, different types of inheritance, etc. And in this lecture, we are first of all discussing the term polymorphism. Polymorphism is originally a Greek word that means the ability to take multiple forms. In object-oriented paradigm, polymorphism implies using operations in different ways depending upon the instance they are operating upon. Polymorphism allows objects with different internal structures to have a common external interface. Polymorphism is particularly effective while implementing inheritance. For example, let us consider two classes circle and square, each with a method find area of. Though the name and the purpose of this method in the class are same, the internal implementation, that is the procedure for calculating the area, is different for each class. When an object of the class circle invokes the find area of method, the operation finds the area of the circle without any conflict with the find area method of the square class. So as of this property, both of these have the same method name, but the internal operation or the calculating methods are different. So this is known as polymorphism, existing in same name but the operations are of different types. And the term is generalization and specialization. Generalization and specialization represents a hierarchy of relationship between classes where subclasses inherit from superclasses. When it comes to the term generalization, in generalization process, the common characteristics of classes are combined to form a class in a higher level of hierarchy. That is, subclasses are combined to form a generalized superclass. It represents and is a kind of relationship. For example, car is a kind of land vehicle, or ship is a kind of water vehicle, or aeroplane is a kind of air type vehicle. So the generalization represents is a kind of a relationship. Next term is a specialization. Specialization is the reverse process of generalization. Here, the distinguishing features of groups of objects are used to form specialized classes from existing classes. It can be said that subclasses are the specialized versions of superclasses. Next term is the term link. A link represents a connection through which an object collaborates with other objects. Rumbaugh has defined it as a physical or conceptual connection between objects. Though a link, one object may invoke the method or navigate through another object, a link depicts the relationship between two or more objects. Next term is the association. Association is a group of links having common structure and common behavior. Association depicts the relationship between the objects of one or more classes. A link can be defined as instance of an association. We should discuss about the term degree of an association. Degree of an association denotes the number of classes involved in a connection. Degree may be unary, binary, or ternary. A unary relationship connects the object of the same class. A binary relationship connects objects of different or two classes. A ternary relationship connects objects of three or more classes. When it comes to the cardinality ratios of association, cardinality of a binary association denotes the number of instances participating in an association. There are three types of cardinality ratios, namely 1-to-1, 1-to-many, and many-to-many. The first term, that is a 1-to-1 relation, a single object of a class A is associated with a single object of class B. So one class is directly associated with another class. Second one is one-to-many association. A single object of a class A is associated with many objects of class B. That is, one object is associated with more than one or more than two objects. Third one is many-to-many. That is, an object of a class A may be associated with many objects of the class B, and conversely, an object of a class B may associated with many objects of class A. So this relation is known as many-to-many relation. So this is the cardinality ratio relating with association. When it comes to the aggregation or the term composition, aggregation or composition is a relationship among classes by which a class can be made up of any combinations of objects of other classes. It allows objects to be placed directly within the body of other classes. Aggregation is referred as a part of or has a relationship with the ability to navigate from the whole to its parts. An aggregation object is an object that is composed of one or more other objects. For example, in the relationship, a car has a motor. Car is a whole object or the aggregate, and the motor is the part of a car. So aggregation may denote physical containment or conceptual containment. In the physical containment, for example, a computer is composed of monitor, CPU, mouse, keyboard, and so on. So these are the physical containments. When it comes to the conceptual containment of a computer, for example, the computer has software, operating system, and etc., as well as a shareholder may have a share or has a share. So this is a conceptual containment. So these are the two terms or two aggregative denotation, that is physical containment as well as conceptual containment. So my dear student, we had discussed about the different terms associated with object-oriented models. And when it comes to the benefits of object model, now that we have gone through the core concepts pertaining to the object orientation, it would be worthwhile to note that the advantages that this model has to offer. The benefits using of object models includes: it helps in faster development of software. Secondly, it is easy to maintain. Suppose a module develops an error, then a programmer can fix that particular module while the other part of the software are still up and running. Thirdly, it supports relatively hassle-free or tension-free upgrades or updations. Fourthly, it enables a reuse of objects, designs, and functions. And another important advantage is it reduces development risk, particularly in integration of complex systems. So my dear students, in the last two lectures, that is this lecture and the previous lecture, we had discussed about the different terminologies associated with object orientation. So dear students, I hope that you had understood these terminologies. So my dear students, kindly go through this assignment question. Our question is, define the following. First one, polymorphism. Second one, generalization. Third one, specialization. Fourth one, link. Fifth one, association. Sixth one, degree of an association. Seventh one, cardinality ratios of association, aggregation or composition, and finally the benefits or advantages of object model. So my dear students, in the upcoming set of lecture, we are discussing the object oriented system or OOM, that is object oriented modeling. So dear students, see you soon. Until then, goodbye, thank you, and all the best.